Assalamualaikum, my name is Nur Fatihah bint Kamal Nazri. My metric number is AE190073. So, we are from group 5 of section 1. We'll be presenting of the design and development of the buck converter. So, we will start with the introduction. A lead acid battery is the most convenient and worldwide used battery. It also have a low cost maintenance and rechargeable. It is good for energy storage, emergency power backup, and charging the PV system. To charge the lead acid battery, it is include primary power source application and standby or backup force application. The regular charging combines constant current followed by stable voltage and used for basic power source application. The rapid charging combines constant current followed by 2 phase of steady voltage and used for complex power source. To do this charging process, we use the DC to DC buck converter with SMC and monitored the charging current and battery voltage. A battery charger was proposed using the full bridge of DC-DC converter connected with the SEIPC converter for power factor adjustment. In this project, we create a battery charger with a DC to DC buck converter. The converter convert a 12 volt DC input source to 3 volt output voltage. So, we will move on to the next part. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Naim Rizwan bin Zaid. So today I would like to present the methodology of buck converter. I am from group 5, section 1. So this is the figure for buck converter as known as buck step down voltage regulator. Because they make voltage go down, it is type of DC converter, so it does the project by using a pair of transistor switches and a piece of wire. So next, in that picture, we see a switch that made of power electronic like a MOSFET, IGBT, and BJT. By giving the switch a PWM signal, the switch will turn on, means on and off. The process of the buck converter is like of PWM dimming. We were all aware that a WM signal was causing the light to dim. A short duty cycles results in a low average voltage observed by the load, which increases when the duty cycle is raised. While a crude WM signal oscillates between high voltage level and ground, no sensitive load such as a microcontroller desire this. Not an average voltage is required. This show the output is clean when using an RC channel. The filter voltage is proportional to the WM signal duty cycle. The duty cycle was increasing the output voltage. Next, as you can see, this is a design planning for the buck converter. In this schematic diagram shows in figure there is an inductor, a capacitor, and the two switching parts, which is MOSFET and diode. This project needs a 12 volt source and a 3.6 output voltage. The buck converter block operating architecture. So the ideal switch is regularly turned on and off during normal operation of the buck power fault stage, with the on and off period being regulated by the control circuit. At the switching frequency of the pulse width modulation rate, this transition is active. This switching action generates an outgoing direct current voltage at the junction of the ideal switch, capacitor, and inductor, which is then filtered by the LC output filter. The duty cycle is output to the PWM generator, which provide signal for the DC buck converters MOSFET. So the MOSFET is turned on and off in response to the PWM signal, generating the desired output voltage. So next, for the buck converters duty cycle, as we can see, the duty cycle of the switch can be changed to change the ratio of the output voltage to voltage that came in. The voltage, the longer the switch is on, the more voltage comes out. Most of the time, duty cycle of a switch is called the converter's duty cycle. You can make a 100% efficient conversion if the switches and inductor are lossless. This is mean that no power goes out during the conversion. This means that the the power is on 60% of the time and off 40% of the time. If you see that the electricity is on 50% of the time and off 50%, that means that is on for half of the time. Okay, that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Aika bin Syariman, and today I will be explaining on the design calculation and the simulation. So firstly, we set the value for the voltage input per volt and voltage output is equal to 3.6 volt. So as this is a buck converter project, so it is normal to see a voltage input is bigger than the voltage output. And then the frequency is set at 20 kilohertz, and then we proceed to the first task, which is to find the duty cycle. So duty cycle is equals to V out over V in, and then we simply insert the value and we get at 0.3 value. And then to find the filter inductance, so just insert the duty cycle value and the voltage input value, and as well as the current value. So to obtain the inductance value here, so we simply do a substitution and then we will get the answer at 157.5 microhenry. So the next one is filter capacitance. Similar to the filter inductance, we just insert the value. Here the value of filter inductance, and then we substitute the switch places, and then we will get the capacitor value at 250 microfarad. And then the minimum inductance we will get at 192.5 microhenry, and the minimum capacitance we get at 0.7 microfarad. And then let's proceed to the simulation, which will using this value from the calculation that we had done. So here is the simulation. So basically, buck converter consists of diodes, inductor, and capacitor, and also the resistance. So in this simulation, we have set the DC voltage source at 12 volt, the inductor value here at 157.5 microhenry, and then this capacitor here at 250 microfarad, and this resistance at 11 ohm. So to obtain this, to obtain the input current, input voltage, and current output, and also the voltage output, we simply insert this part here to the scope, and then simply press run, and then we can obtain the scope here. So it is proven that the voltage input here is set at 12 volt, and then we obtain the voltage output here at 3.6 volt. So I think that is all for the simulation part and calculation part. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hanafi Adli bin Ahmad Sobri, and I will be presenting for the result and discussion. So for the result, this is the graph we get from the simulation, which is the first graph is input voltage versus time. The second graph is graph for the input current versus time. The third graph is output voltage versus time, and lastly the graph for the output current versus time. So in table 1.1 is the value of simulation we got in our MATLAB. All of this is a simulation of the value that we got from the simulation, which is the V in is 12 volt. For the load is 157.5. For the resistor we got 11 ohm. For the V limit we got 20 millivolt. For the V naught we got 3.6 volt. For the capacitor we got 250 microfarad. For inductor loads we got 0.8 ampere, and for the frequency we got 20 kilohertz. And lastly for the pulse width we got 30%. Next I will be tell about the discussion. So although the regulating DC component of a pulse output may be sufficient for some purpose, it is frequently the goal to obtain an output that is entirely DC. So inserting a low pass filter after the turn is one method of obtaining the desired output. So basically the basic converter is connected to a low pass conductor capacitor, which is LC filter, which reduce the amount of noise. So when the switch is open, the diode directs the inductor current in one direction, and when the switch is closed, the diode reverse the current direction. So this circuit is referred to as a buck converter or a down converter since the output voltage is less than the input voltage. So the advantage of using this is that there are a wide range of tolerance for line voltage variation, and they are inexpensive and are small in size. So you cannot is the buck converter is extremely basic, requiring only a single power switch to operate. It's estimated that the buck regulator has efficient approximately is 90%. So the drawback of the buck converter, its poor transition response of a significant output ripple. Both are undesirable, and the input filter is often required to a buck converter in most cases. Okay, that's all for the discussion part. Lastly, I will be present for the conclusion. So based on the project, we may conclude that the outcome of this experiment may be acceptable. The buck circuit was chosen as the project, and the student designed it using MATLAB for the simulation. If the result is positive, the minimal inductor is suggested, and the continuous circuit mode is suggested. Everything is usually computed from the result of the calculation. It might be claimed that the student prefer a lead acid battery as an alternative to creating a buck circuit design. So basically the flow of the procedure is complete from the flowchart in order to convey it as clearly as possible while making it clear and exact. Okay, that's all from me. Thank you.